This is about angle properties of a circle. We need to understand some rules. Rules number 1 said angles in the same segment are equal. If you see the diagram very well, you see angle X is angle at circumference. The other X also angle at circumference. Both angles subtended by the same arc. They are located at the same segment. So we have conclusion that those angles are equal. How to remember easily this rule number 1? You can imagine that you see the wing of butterfly. Triangle on the left contains angle X. Triangle on the right also contains angle X. These two triangles shape the wing of butterfly. And this is remind you of the angles in the same segment are equal. A cyclic quadrilateral is quadrilateral that the 4 vertices are located at the circumference of the circle. Or you see that this quadrilateral is formed by 4 chords. Rules number 2 said that the opposite angles in a cyclic quadrilateral add up to 180 degrees. You see that angle W plus angle X is equal to 180 degrees. They are opposite angles. And also angle Y plus angle Z equals to 180 degrees. In other words, you may say that Y and Z are supplementary angles. In this diagram, you have two kinds of angles. The first angle has the vertex at the center of the circle. It is written as 2x degrees on the diagram. So we have angle at center is equal to 2x. Then we have another kind of angle, which is the vertex is at the circumference of the circle. And the size is x degrees on the diagram. So we have angle at circumference equal to x. Now these two angles subtended by the same arc. So they have a special relationship. Angle at the center is twice the angle at the circumference when they are subtended by the same arc. In rule number 4, we have a line from the center of the circle perpendicular to the chord. This line we call as upper thumb. Upper thumb always perpendicular to the chord and bisect the chord become 2 equal parts. If you draw the radius of the circle from the center to the end of the chord, then this radius, upper thumb and half of the chord, they will form a right angle triangle where you may use your Pythagoras formula. In this diagram, we have a line touching a circle at a single point. This line is called the tangent to a circle. Rule number 5 said the radius will always meet a tangent at 90 degrees. Rule number 6 said that the tangents from the same point to a circle are equal in length. So in the diagram, you see that the length of AB is equal to the length of BC. We will add one more special properties for this rule number 6. You have angle AOC, which is angle at center, angle AOC plus angle ABC is equal to 180 degrees. Once again, angle O plus angle B is equal to 180 degrees. We will combine rule number 1 and number 3 for this diagram. You see in this diagram, there are 3 angles at the circumference which is located in the same segment. That 3 angles are equal. And also, these 3 angles subtended by the same arc, which is a semicircle. The size is 180 degrees. So we have rule number 3 said angle at circumference half of angle at center. So when your angle at center, which is semicircle 180 degrees, then we will have angle at circumference half times 180 degrees equals to 90 degrees. So rule number 7 said the angle inscribed in a semicircle is always a right angle. Rule number 8 gives us the alternate segment theorem. The angle between the tangent and the side of the triangle is equal to the opposite interior angle. Notice in the diagram, we have angle y below and angle y above. The angle y below is the angle between the tangent and the side of triangle. And this angle y below is equal to the angle y above, which is the opposite interior angles. And this will be the same for angle x below and also angle x above. The angle x below is angle between the tangent and one side of the triangle. This angle x below is equal to the angle x above, which is the opposite interior angle. Once again, remember this rule number 8 is the alternate segment theorem. In the diagram, you have angle at circumference is 55 degrees and angle at center is alpha degrees. Which circle theorem rule is used to find angle alpha? And the answer is angle at the center is twice the size of the angle at the circumference. How to calculate the size of angle alpha in this diagram? Because we have the rule said that angle at center is twice the size of angle at the circumference, so alpha is equal to 2 times 60 degrees. Alpha is 120 degrees. Which circle theorem rule is used to find the angle x? Remember our imagination about the wings of butterfly? The theorem is angles in the same segments are equal. In this diagram, you have angle at circumference 38 degrees and the other angle at circumference x degrees. Both of them are located in the same segment and that both of them also subtended by the same arc. What is the size of angle x? The theorem said angles in the same segment are equal. So, angle x is equal to 38 degrees. In this diagram, you see a line touching the circle at the point of tangent. Then you also have the radius perpendicular to the tangent. So, which circle theorem rule is used to find the angle y? The answer is the angle between a tangent and a radius is always 90 degrees. How to find the size of angle y in this diagram? You need to remember two theories to solve this angle y. Theory number 1 is the sum of interior angles in a triangle is equal to 180 degrees. The second theorem is radius is always perpendicular to tangent, so you have 90 degrees angle. Then we calculate y plus 90 degrees plus 30 degrees is equal to 180 degrees. Then angle y is equal to 60 degrees. The next question is, which circle theorem rule is used to find this angle M in the diagram? Remember, rule number 8 said that the angle between the tangent and one side of the triangle is equal to the opposite interior angles. And this theorem is called the alternate segment theorem. For this question, find the size of the angle M. Then we will use the alternate segment theorem that angle M is equal to 70 degrees. How to find the size of angle X in this diagram? We will use the theorem rule that angle at center is twice the size of angle at circumference when both of them subtended by the same arc. So the angle X is equal to 2 times 32 degrees. X is equal to 64 degrees. We already have X equals to 64 degrees from the previous question. And now, how to find the size of the angle Y? We will use the alternate segment theorem, which is the angle at C, 72 degrees, will be equal to the opposite interior angles at B, also 72 degrees. Then you will see there is an isosceles triangle inside the circle. Isosceles triangle AOB. How to find the angle at the foot of this triangle? The way is 180 degrees minus 64 degrees and divide by 2. So we have the angle at the foot of the isosceles triangle. Each of them is 58 degrees. Then we can calculate the size of angle Y from 72 degrees minus 58 degrees, and the answer is Y equals 14 degrees.